Welcome to the Outdoor Cable Installation module. In this module, we'll be covering the installation considerations for the outdoor segment of the infrastructure. This may not be in your domain of responsibility, but is given as a guide to help understand the requirements. There are important differences between the cabling and techniques used in indoor and outdoor cabling. The network backbone links between buildings must use cabling that conforms to different standards to those for indoor types. There are also a range of installation techniques specific to outdoor cable runs. Note, this module discusses installation of coaxial cable, but equally applies to the new trend in fiber to the home or unit applications, where the coaxial cable is replaced with fiber optic cable. Cables used are placed underground in new or existing tunnels, conduits, or ductwork, or they are directly buried. Alternatively, they can be installed aerially between buildings. The environment they will be exposed to is the key factor in selecting outdoor cables and deciding how they should be installed. Weather, in particular likely storm loading, is the key environmental factor for aerial cabling. All factors being equal, underground installations using ductwork are the most popular method, although any of the other methods can be used if they are more cost-effective or appropriate to the location. Aerial installations offer several advantages, not the least of which is having a lower cost than direct burial. In addition, they can usually take a direct route between buildings since they easily cross obstructions such as roads, drains, power cables, gas pipes, and the like. Their chief disadvantage is that they tend to be more environmentally exposed, especially to wind, ice, and falling tree limbs. However, a properly installed aerial cable should be able to withstand severe weather without problem. Aerial cable is usually messengered. That is, it comes with an attached high-strength messenger wire that supports the transmission cable. The length of the span between supports is determined by the weight of the cable. Aerial installations fall under National Electrical Safety Code or NESC rules. Before attempting such installations, ensure you are familiar with the appropriate part of the code. This chart, derived from NESC publication, shows the clearances required for a fiber cable meeting NESC rules 230C2 or 230C3, depending on the type of surface it spans. Take a few minutes to study it. For a complete listing, contact the NESC. In addition to midspan surface clearances, the NESC rules also specify the midspan clearances between cables that share the same supports, as shown in this diagram. Clearances at the points of attachment are also specified by the code. The NESC code also includes detailed rules for cable clearances around buildings. These are quite complex, as you will see by studying this diagram, indicating different clearances in different areas. The aerial section deals with the installation of messengered fiber cable. The maximum length for messengered spans varies for the size and fiber count of each cable. Check span data prior to ordering cable, or one may install a messenger cable and lash the fiber optics cable to the pre-installed messenger. When choosing a route for aerial cables, look for a path between the buildings that avoids trees with overhanging limbs. If the cable has to pass over a public road or railroad, be sure to get right-of-way permission from the correct municipal or transportation authority. Keep in mind the NESC minimum clearances in the table in the previous slide. Begin the installation by locating points of attachment on the buildings. The attachment point should not be any closer than 10 centimeters or 4 inches from a telephone cable, or 30 centimeters or 1 foot from a power line. Use a P or Q hook used in CATV installations screwed through or bolted into a wall or other structural element. The hook will have to support the hanging weight and tension of the cable under storm conditions, so be sure it's securely attached and the proper size and rating. Set up the cable reel beneath one hook and walk the cable end toward the second attachment point. Avoid kinking, scraping, or tangling the cable as it pays out from the reel. Block traffic from running over the cable. Once at the destination, continue to pull enough cable to cover the distance from the attachment point to the building entrance facility. Measure the distance carefully and include extra cable for the service loop. Another way of making sure enough cable has been pulled is to carry the cable up to the attachment point. The cable can then be marked with a strip of vinyl tape to show where to stop separating the messenger from the cable. In any case, pull a few more meters of cable than your most liberal estimate of the amount required to reach the entrance facility. Neatly figure 8 the excess cable. The time you take in examining the site prior to installation is well spent and can help you avoid problems later on. You need to be aware of issues such as right-of-way or ROW, where you will tap into the span, the distance of the run, and where you will attach and bond the cable at the customer's structure. A 60% braid foil shield works for almost all CATV installations. If you are installing cable intended for a more active two-way service, internet high-speed data, you should consider a tri-shielded cable. Cellular and pager towers produce radiation that tends to raise havoc with CATV channels 19, 20, and 21. Ham radio aerials may also signify a problem. Urban zones have inherently high levels of RF pollution. We recommend tri-shielded cables with a minimum of 60% braid for areas with high RF concentrations. Know your ROW, right-of-way. The most direct route may not be the legal route. Make sure the route you're planning runs only over the customer's property. Generally, you can follow a parallel path to power or phone lines. However, under no circumstances lash your drop to any other cable. While most spans have taps located next to the poles, you may occasionally find a tap in mid-span. This may be helpful in avoiding ROW issues. NEC 820 specifies that coaxial cable must be bonded, preferably with the electrical. Therefore, try to attach the cable to the wall or corner nearest the meter. If that can't be reached, an exterior cold water pipe, if the plumbing throughout the building and back to the main is entirely metal, or an existing ground rod will do. If these are impractical, you will have to hammer in a ground rod. In most cases, you will be selecting the cable entry point into the building. However, if the NIU is already in place, try to attach your cable as close to it as you can, keeping bonding considerations in mind. The top example shows a pretty straightforward installation. The electric meter is on the opposite side of the building from the span, so attachment near the cold water tap is acceptable. The middle example shows that the most direct route would trespass on neighboring property. Therefore, the drop should be run along the span and then angled to the building, eventually running toward the meter and then back to the point of entry. Be sure to check mid-span. It is possible that there may be a tap there because a pole was there at one time. The bottom example is a tough call. It's marginally shorter to attach near the point of entry, run to the meter for bonding purposes, and double back to the point of entry. In all cases, check your local code requirements and system design specifications for your prescribed bonding requirements. For best efficiency and lowest cost, aerial installation is generally preferred. However, local or subdivision codes sometimes require that utilities be installed underground. There are times the customer may want the cables hidden for aesthetic reasons. In these cases, see later for instructions on buried installations. A typical installation is shown below. A continuous length of cable runs from the tap to the attachment point and continues to the grounding point called a ground bond block. A second cable continues from the ground block through the point of entry to a termination point within the structure. Some systems use coaxial or UTP cable to carry power as well as the signal to the NIU, Network Interface Unit, sometimes called a NID, Network Interface Device. When installing powered coax cable carrying up to 150 volts, pay special attention to the cable-to-earth distance as shown in the diagram. NEC 830 also requires that cable attached to the building within 8 feet or 2.5 meters of grade must be placed within conduit, raceway, or some other approved cable guard. NEC 830 installations will terminate at an NIU. Most NIUs have built-in connections that must be grounded at the meter or other approved point. Set up your cable pack or A-frame beneath the tap. Take the cable end and walk toward the attachment point. Don't let the cable kink, scrape, tangle, or get hung up as you walk. It may deform the cable and cause transmission problems later. Keep pulling cable after you reach the attachment point. Remember, you need to have enough cable in hand to run along the soffit or foundation line of the building to reach the grounding point. Go back to the reel and pull enough extra cable to reach the tap. Cut the cable at the reel. Taking the cable in hand, climb or ride up to the second attachment point. Pull the cable taut until the sag is 1% of the overall length of the span. That is, for a 30-meter or 100-foot span, the sag should be 0.3 meters or 1 foot. Mark the place on the cable where the cable and the hook meet while maintaining proper sag. Do not pull the cable through or attach it to the hook at this time. Then, prepare to cut the messenger by selecting a point on the cable at least 60 centimeters or 2 feet beyond where the cable and hook would meet. Using wire or side cutters, cut the messenger wire, being careful not to nick the cable jacket. Separate the messenger from the cable by using heavy wire cutters to start a split in the webbing between the messenger and the cable. Take the messenger in one hand and the cable in the other and smoothly pull your hands apart to split the webbing. Pull across the webbing, known as a scissors pull, instead of pulling the webbing directly apart. Separate the messenger and cable up to the calculated or measured point of attachment. Cut off the excess messenger, leaving about 60 centimeters, 2 feet, for attachment. Attach the messenger to the building. If the messenger is stranded wire, use a strand vise and attach it per the manufacturer's instructions. If the messenger is solid wire, use the 2-4-4 method to tie it off. The messenger is threaded 2 times through the hook, wrapped 4 times around the messenger itself, and 4 times around the messenger and cable. Take the 60 centimeters or 2 feet of messenger and thread the messenger through the hook twice. Pull it tight. The unseparated messenger and cable should be about 15 centimeters or 6 inches from the hook. Wrap the messenger 4 times tightly around itself. Wrap the messenger 4 times around the messenger and cable. These multiple loops distribute tension and help keep the cable from deforming. Finally, knot the last loop in a simple clove hitch. Trim off any excess messenger. Attach the cable to the building. Using the scissors pull, strip the unused messenger from the cable. Secure the cable to the building with cable clips or similar devices. If possible, place the cable along architectural elements that will hide it. For coaxial cable installations, the cable should be connectorized per the instructions on coax connectorization. Some systems like to protect the connection with a shield, a physical covering to protect against tampering. Place that over the connector now. You will require an F-connector tool to tighten the connection. With the messenger secured to the span, secure the connectorized cable into the tap hand tight. Using a torque wrench, tighten the connector to 30 pounds-inch. If you don't have a torque wrench, twist the connector an extra 1/4 turn with your wrench or F-connector tool to seat it. Cover the connection with a boot. You should have about 2 feet or 60 centimeters of cable between the tap and where the cable joins the messenger. Along with the ease of handling this provides, this extra cable will be very useful if you ever need to reconnectorize the cable. Store this cable by forming a loop of about 6 inches or 15 centimeters in diameter. Make sure the diameter of the loop is no smaller than 10 times the outer diameter of the cable. Use cable ties to form and secure the loop to the span. Attach an identification tag to the cable. Using a ladder or a lift truck, climb up to the attachment point and screw or drive the P-hook or Q-hook into the residence. Use an insulated hook if you are bringing in powered service per NEC 830. A good attachment point is the corner of the house under the soffit. Never attach it to an antenna, rain gutter, chimney, power mast, or lightning rod. The hook should be parallel to the ground. The attachment point should not be any closer than 4 inches or 10 centimeters from a telephone cable or 1 foot or 30 centimeters from a power line. Make certain you meet all clearance requirements. Taking the cable in hand, climb up to the attachment point, pull the cable taut until the sag is 1% of the overall length of the drop. Examples: for a 100-foot run, the sag should be 1 foot. For a 50-foot run, the sag should be 1/2 foot. Use your hand to mark the place on the cable where the cable and the hook meet while maintaining proper sag. Do not pull the cable through the hook or attach it to the hook. Select a point on the cable at least 1 foot or 30 centimeters beyond where the cable and hook would meet. Using side cutters, cut the messenger wire, being careful not to nick the jacket of the coax. Pull the messenger and the coax apart to produce over 1 foot or 30 centimeters of messenger. Shear, don't tear the cable. Using the 2-4-4 method described earlier, attach the messenger wire to the hook or use a messenger wire clamp. Strip the remaining messenger wire from the coax. Route the cable from the attachment point to the grounding block or the entry point for the NIU. The path should follow the architectural details of the residence, running down at the corners and across at beams and seams in the siding. Use cable clips to attach the coax to the house. A variety of screw-in or nail-in clips are available for wood and masonry. Special snap-in clips are available for vinyl and aluminum siding. Never staple coaxial cable. Stapling will deform the dielectric and may damage the shield. In either case, a loss of performance will result and you will have to replace the cable. Place your first clip so as to allow for a small drip loop. Then place the clips about every 3 feet or 1 meter for vertical runs and no further apart than 18 inches, 0.5 meters on horizontal runs. Make sure you do not kink or bend the coaxial cable tighter than the recommended bend diameter, usually 10% of its outer diameter. Check your cable specs to be certain. All coax connections to the grounding block or splitters must be horizontal. Underground service has become popular in many developments and subdivisions. Broadband services are brought in by buried cable and accessed by pedestals, which are usually at the property line. While the easiest way to run the cable is to trench or plow in a burial-grade coaxial cable to a minimum depth of 12 inches or 0.3 meters, burying cable pre-installed in conduit is a far better method. Cable in conduit, or CIC, offers greater physical protection against environment, abrasion, rocks, and so on than direct burial, which can prolong the life of the cable. And should the cable ever fail, it can be replaced without digging up the yard. CIC of 1/2 inch 13 millimeters to 3/4 inch 21 millimeters is recommended. If you are directly burying cable without using conduit, you should use an 18-inch or 45 centimeter length of it to protect the cable 6 inches or 15 centimeters below and 12 inches or 30 centimeters above grade where it emerges next to the residence. Systems that use coaxial cable to carry up to 150 volts of power as well as signal to an NIU fall under NEC 830 regulations. Pay special attention to the buried cable depth as shown in the diagram. Note that CIC HDPE conduit doesn't need to be buried as deeply as direct burial installations. Although NEC 830 permits the use of metal conduit, CommScope does not recommend its use. Problems with rust, water migration, and potential damage to the cable jacket due to cutting and scraping during installation are possible results of using metal conduit. Frozen water will crush cable in a metal conduit, but HDPE conduit will allow the ice to expand and save the cable. Direct burial cable and cable in conduit CIC may be installed by trenching or plowing. When plowing, select a plow chute with a bend radius no smaller and preferably larger than the minimum bend radius of the cable or CIC you are installing. The chute width should be at least 1/2 inch or 1.25 centimeters larger in diameter than the cable or CIC. At the pedestal, dig a trench deep enough and at least twice the length of the plow blade or chute for the plow blade to enter it comfortably. A similar trench should be dug near the attachment point at the residence. The cable and CIC may pay off from the front of the walk-behind plow or from a stationary reel along the route. Carefully pull enough cable and CIC through the blade to comfortably allow for connectorization. Once the blade is completely in the ground, manually feed the cable and CIC into the plow blade. In the walk-behind plow method, pay the cable and CIC over the top of the reel. Do not use reel brakes. In the stationary reel method, pull the cable and CIC end from the reel to the starting trench. With CIC, make sure both ends of the conduit are capped. The trench should be dug as straight, level, and rock-free as possible. Avoid tight curves. If there are rapid grade changes and you are installing CIC, use backfill to support the conduit. Taking into account NEC 820 and 830 considerations, dig the trench to correct depth. Mount the reel so that payoff is underneath toward the direction of the pull. If using CIC, make sure the conduit is capped. Pull enough excess cable to permit easy installation at the attachment point and enough to reach a few feet beyond the pedestal. When in doubt of the exact length, always pay out more than you think you will need. Dig a receiving pit to the depth required by either NEC 820 or 830 depending on your application, between 12 and 18 inches, 30 and 45 centimeters, see page 7.2. The pit should be about 6 inches or 15 centimeters wide and 18 inches or 45 centimeters long and run in the direction of the planned line of the installation. The plow blade should be able to fit easily inside it. Feed your cable or CIC through the plow blade and run it to the bottom of the pit and up through the pedestal base. The rule of thumb is to leave at least 10 times the outer diameter of the cable for easy connectorization and leaving some spare cable for connector replacement. If using CIC, tamp some dirt in as backfill support for the curve of the conduit. If you are using CIC, keep the end capped until you've initially placed the cable. Use a ratchet shear to trim off the excess conduit. Fill the cable end with a watertight sealing foam. If trenching, unreel your cable or conduit as shown earlier. The only difference is that you will not need a receiving pit as you will already have the trench dug. If you are plowing in the cable or CIC, make sure you have dug a receiving trench to the attachment point of the residence. Run the plow along your planned route to the attachment point. Remember that for NEC 830 considerations, cable not in conduit must be buried at a depth of 18 inches or 45 centimeters. You may not be able to run the tractor directly to the attachment point. If not, dig a larger receiving pit. If you are trenching the installation, dig a trench of the correct depth from the pedestal to the attachment point on the residence. After the cable has been placed, connectorize the cable per the instructions. Once the cable is connectorized, attach it firmly to the tap. Leave a loop of cable 10 times the outer diameter of the cable to allow for expansion and to leave extra cable should reconnectorization ever be required. Use the sealing sleeve to protect the connection from moisture. Attach an identification tag to the cable. This is especially important if there are multiple taps at the pedestal. Use a cable tie to secure the lower part of the cable to the pedestal in order to keep the cable out of any dirt or water. If you are using conduit, seal the end of the conduit with either a waterproof expanding foam or with a duct cap. Once the cable is connected and the connection sealed, close the pedestal. Unreel the cable and CIC by hand until you have more than enough to reach the attachment point. Always err on the side of having too much cable. If you have installed CIC, determine how much conduit you need to reach the attachment point. Using a ratchet shear, cut off the excess conduit to reveal the cable. Attach the conduit to the wall by using U-clamps. If you are not using CIC, use an 18-inch or 45-centimeter piece of HDPE or PVC conduit to protect the cable where it exits the earth. Place the conduit over the cable and run it down to the trench. Secure the conduit to the wall with U-clamps so that 6 inches or 15 centimeters of cable is below grade and 12 inches or 30 centimeters is above grade. Seal the end of the conduit with either a waterproof expanding foam or with a duct cap. Some installers favor an enclosure on the wall for the attachment point. If so, run enough conduit so as to touch the base of the enclosure, connecting the conduit using the enclosure manufacturer's instructions. NEC Article 820 states that the ground block should be attached to the wall as close as possible to the electrical meter. Both the ground wire and the coaxial cable connection should run horizontally. The grounding wire should be as straight as possible. The preferred bonding method is to attach the ground block's bonding wire to the electrical meter ground wire with a wire not less than 14 AWG in size. For recommendations regarding ground wire sizes, please refer to the National Electrical Code, NEC 820-40, or your local building code. If bonding the ground block to the meter is not possible, you may bond to an exterior metal cold water pipe running into the earth. As a last resort, you may drive an 8-foot ground rod into the earth and attach the bonding wire to that, but you will need to ground all of the grounds of the residence to that rod. Bond mobile homes at the electrical service tap. If there is no service tap, you may bond to the frame of the mobile home using a wire no smaller than 12 AWG. Never bond to the siding of a mobile home. Once the ground is attached, cut the coax so that you have a sufficient amount to reach the ground block comfortably, plus about another 1 foot or 30 centimeters. Connectorize the cable and attach it to the ground block. Then form a 6-inch or 15 centimeter diameter loop and secure it with a cable tie. This extra cable will be useful if you ever need to reconnectorize the cable. NEC Article 830 covers the installation of cable from the tap to the connection of the NIU. NEC 830 rated cables supply the voltage that powers the NIU. The NIU then distributes the various signals coming in over the drop, CATV, internet, telephone service, and so on onto the preferred cable and connections that branch from the NIU throughout the residence. These interior cables, NEC 820 coax, NEC 800 twisted pair, NEC 770 fiber optic, carry very low, if any, voltage. NEC 830 requires that powered broadband cables that are attached to a building within 8 feet or 2.5 meters of the finished grade must be protected by molding or conduit. If you are using CIC, this requirement is easily met by extending the conduit from the ground to the entry point. If you are using direct burial cable without conduit, you must run the cable in a conduit starting 18 inches or 45 centimeters below finished grade and finishing in contact with the NIU enclosure. With an aerial installation, the cable should be placed in conduit with a J-joint at the top to prevent water from getting into the NIU, and then run to the top of the NIU enclosure. You should attach the NIU to the wall as closely as possible to the electrical meter. The bonding wire is attached to a point within the NIU enclosure. Specific bonding points will vary with each make of NIU, so please consult the manufacturer's instructions. In all cases, the bonding wire should be as straight as possible and run horizontally to the attachment point at the meter. The preferred bonding method is to attach the NIU's bond to the electrical meter ground wire with a wire not less than 14 AWG in size. For recommendations regarding ground wire sizes, please refer to the National Electrical Code or your local building code. If bonding the NIU to the meter is not possible, you may bond to an exterior metal cold water pipe running into the earth. As a last resort, you may drive an 8-foot ground rod into the earth and attach the bonding wire to that, but you will need to attach all of the grounds of the residence to that rod. Once the ground is attached, cut the coax so that you have a sufficient amount to comfortably reach the connection within the NIU, plus about another 1 foot or 30 centimeters, similar to the pedestal attachment. Connectorize the cable and attach it to the NIU. If the cable is entering from above, form a small drip loop below the connection of the cable and the NIU. This loop will be useful if you have to reconnectorize the cable in the future. By now, the drop has been run to the residence, attached, and grounded at either the ground block or the NIU. How and where you enter the residence depends on the types of service that are going to be provided. If there is no NIU, you need to proceed from the ground block to the various locations around the residence, splitting the connections as you go. It may be to your advantage to use a ground block with a splitter so that two coax may be run in different directions. With an NIU, multiple and different cabling types may be used on the output side. A general rule is that CATV coax may be split, but phone and computer UTP should be home run to the NIU. Cable modem should be placed at the first split. For the ground floor, plan your installation so that the cable runs through the crawlspace or basement and then up through the floor or an interior wall to the outlets. For the upper floor, run up to and through the attic and then down through the walls to outlets. If the crawlspace or basement presents problems, another option is to run the cable around the outside of the residence. Be sure to use an outdoor-rated cable. Try to follow the architectural lines of the house and run the cable in places where the foundation meets the bottom of the exterior walls or vertically along the corner trim or under the soffit. You can bury cable next to the foundation, keeping in mind the burial depth per NEC 820. Avoid placing cable in direct sunlight, as that will accelerate cable aging. Consider a non-metallic raceway to hide and protect the exterior cable. That completes the outdoor cable installation module. Thank you.